All right, so this one, as with the constant multiplier, theorem 3, we can use the four-step process for the following two items to obtain theorem 4. So basically, the derivative of the sum of two differentiable functions is the sum of the derivatives of the functions, and the derivative of the difference of two differentiable functions is the difference of the derivatives of the functions. So together, we get that sum and difference property here as shown in theorem 4. So y equals f of x is equal to u of x plus or minus v of x. So if we do the sum, we'll do the top one. If we do the difference, we're doing the bottom. So it's basically, if we take the derivative of that, we're going to take the derivative of the first, and then plus, if we're using plus, the derivative of the second, or derivative of the first minus the derivative of the second. Again, depending on if we have an addition or subtraction between them. And again, just using different notation, we have y prime or dy dx, and we can do that. Now, this rule generalizes to the sum and difference of any given number of functions. So it doesn't matter how many functions it is, you can go out, 10 million things and just take the derivative of each one, add them or subtract them together. So now that we have theorems 1 through 4, we can compute the derivatives of all polynomials and a variety of other functions. So some algebraic rewriting may be required, as you've seen up to this point, before we can apply the rules, but we can apply most of these rules and solve the problems. So let's look at a few examples here. For the first one, we're looking for the derivative of, and it's this polynomial function here. And well, what that is we can use theorem 4. We're going to have a difference, then we're going to have a sum, then we're going to have a difference, and then we're going to have a sum. And so basically, we just have to find the derivatives of this, the derivative of that, derivative of that, derivative of that, derivative of that, and then, put the appropriate plus or minus in between them. So f prime of x is going to be equal to what? Well, here, we're going to bring that down and multiply. So 3 times 4 is going to give us 12. Then we'll have x, 4 minus 1 is 3. Now we're going to have a subtract. Now we have, bring the 3 down. 3 times 2 is 6. Now 3 minus 1 is 2, so it's going to be x squared. Here, we'll bring that down. That's going to be plus 2x. 2 minus 1 is 1, so we can just leave it as 2x. Here, this is a 1. Remember, if you don't see anything, it's a 1. So bring it down. 1 times 5 is going to be minus 5. Subtract 1 is 0. X to the 0 is going to be just 1, so we just have 5. And here's our constant, so the derivative of that's 0. And so that is our derivative of that polynomial. So pretty easy so far. All right, what about b? Well, guess what? It's just another polynomial. It just looks different format. So y prime is going to be equal to what? Well, the derivative of that is going to be 0. So now we just take this, bring it down here, multiply that. So minus 2 times a minus 7 is going to be a plus 14. And then we have x minus 2 minus 1 is going to be minus 3. And again, if we do the make that a positive, that's going to be x cubed in the denominator. Okay. What about this one? Well, this one we're going to have to rewrite. That's going to have to end up being 5v cubed minus v to the 1/4, because that's the fourth root of v, so it's going to be to the 1/4. And so if we do that, let's go ahead and do that up here, or that's a c rather. So if we do that, we're going to take and multiply that times here. So 3 times 5, so that's going to give us, and this is going to be dy dv is equal to, that's going to be 15v, 3 minus 1 is 2, minus, now we have 1/4 times that, so it's just going to be a 1/4 v, 1/4 minus 4/4 to get the common denominator, so it's going to be minus 3/4. And then we can rewrite this with the positive, and so that's going to be a 15v squared minus 1/4. That's going to be the fourth root of v cubed. Okay, so that then 15v squared minus that is going to be our derivative of this function. Now this one, again, it looks more like, 1. It's just a list of terms in a polynomial. But in this case, we have to move those two up and make them negative. So that's going to be a minus 3/4. And now it's going to be x to the minus 1 plus 4x to the minus 3 minus 1/8 x to the 4th. And I also kind of brought out our constants here out in front, because remember, we just find the derivative of the x part, and then we multiply it by whatever that is. So now we can do that derivative. So d now is going to be a minus 1 times a minus 3/4. So that's going to be a positive 3/4. And then we have minus 1 minus 1, so that's going to be x to the minus 2. Now we have a minus 3 times a plus 4, so that's going to be a minus 12x, and minus 3 minus 1 is going to be minus 4. Now here we have a 4 times a minus 1/8, so it's going to be a minus, and 4 over 8 is going to be 1/2, and that's going to be x, and we subtract 1 off there, and that's going to be to the third. Now the only thing left is to make all the negative exponents positive, so that's going to be 3 over 4x squared minus 12 over x to the fourth, and then minus 1 over 2. Oops, I guess that one's not negative. Never mind. We were going too far. That one's just going to be a minus x cubed over 2. Okay? And so that would be then our derivative, d dx is going to be that. All right. One last one here. Find the derivative of this. All right, so this one, well, one last one in this part anyway. This one, we have to think about how that is. Well, we're taking basically each of these terms and dividing them by x. So what if we rewrote this as 5 over x minus 3x over x plus 4x squared over x? Okay, well, that simplifies. Now, let's cancel and make them all with the format of x to the n. Okay, well, so that's that equals, so this is going to be, well, now we can take that up, and that's going to be a 5x to the negative 1. Well, guess what? Here, if we cancel with a different color, that x cancels that x, and so then this becomes a negative 3. And here, if we cancel again, this x cancels one of those, we're left with 1. And so then we have plus 4x. So now that's the actual function f of x that we're going to take the derivative of. All right, so then f prime of x is equal to what? Well, take that, bring it down. Minus 1 times 5 is going to be a minus 5x. Minus 1 is going to be a minus 2. Well, guess what that is? That's a constant, so the derivative of that is 0. And here, this is understood as to being a 1, so it'll be 1 times 4, so it's going to be plus 4x, and that's going to be 1 minus 1, so that's to the 0. Well, that's just 1. So really, all we get here is, now if we make that positive, a minus 5 over x squared plus 4. Okay, and so that would be the derivative of this original polynomial. Okay. All right, so let's stop there, and then we'll come back for one last bit.